Welcome, everybody, and thanks for tuning in. Before I start, I want to say that it's a true pleasure to be presenting again at Virus Bulletin. And today's presentation is going to be about Ramsay, which is a cyber-espionage toolkit we reported back in May, which is tailored for air-gapped networks. So before we start, let me give you a brief introduction about myself. My name is Ignacio Sanmillan, and I'm currently working as a malware researcher at ESET. And prior to work at ESET, I work at Inteser Labs, which is an Israeli-based company that focuses on code reuse technologies. So the agenda for today is going to start by giving a brief overview of what air-gapping is. Then we will talk about the Ramsay framework, its capabilities, and the different versions that we found. Then we will give a brief overview in regards to the overlaps that we found between Ramsay and DarkHotel. We will also show how we think Ramsay is operated, and then we will round it up and finalize with a conclusion. So let's talk about air-gapping. So the following diagram that you can see is usually is a high-level perspective of how an air-gapped network might look like. And air-gapped networks usually have two sides: a closed network, which is the network that wants to be isolated, and an open network, which is the network in which the air-gapped network wants to be isolated from. These two sides can also be known as high side or low side, depending on the confidentiality level of each network. And air-gapping, long story short, is basically a network security measure that can be applied to one or more computers in order to ensure that a given subject network is physically isolated. And this is usually done in order to prevent exposure of the subject network to the internet or local area network. There are various organizations in which air-gapping might be enforced. However, usually air-gapping is enforced in military or governmental computer systems, financial computer systems, or industrial control systems. I will also want to talk about a specific event that took place between May and June 2020, in which we witnessed an increase of reports from different vendors in regards to malware targeting air gaps. And these were USB Ferry, reported by Trend Micro, Ramsay, reported by us, ESET, and then CycleDeck, reported by Kaspersky. And let me say that encountering reports, or at least open or openly available reports, talking about malware targeting air gaps is not very common, as malware, this type of malware, is not very usual to find. But the fact that 3 different vendors reported their own activity set in regards to malware targeting air gaps within a time frame of 1 month is pretty remarkable, and tell us a bit how these kind of networks are increasingly demanded by adversaries. And this high volume, or relatively high volume, of targeting of these networks can classify these networks as high-value targets. And it's very clear that there is a definite incentive in order to target these kind of networks, as they usually secure classified or critical information. However, it's important to also know that operating within this type of networks comes with a trade-off, and operational objectives have to be achieved based on a constrained set of resources. For example, one specific resource that will be almost immediate to think of that won't be accessible from air-gapped networks is the availability of a network-based communication channel. The scarcity of a network-based communication channel, what will actually provoke is to have a poor feedback cycle between operators and their toolkits. In the sense of, if a toolkit actually performs some unpredictable behavior, or simply there is something that goes wrong while operating it, operators are not going to be able to find out about this, as they won't have the means to react quickly to this type of incidents. So what this will lead to is to developers behind these toolkits to design this malware as to be self-reliable. And writing self-reliable malware proficiently is not easy. But on top of that, usually this kind of malware contains some sort of lateral movement capability, which the combination of lateral movement capability with a sort of autonomous malware, what it ends up into is that the control of the proliferation of this malware is actually very hard. However, furthermore, there is also an ambiguous modus operandi of these toolkits, because these toolkits, depending on where the threat actor's foothold is in regards of whether the threat actors have physical presence in the air gap or whether they have a foothold in adjacent networks of the air gap, these kind of toolkits will be leveraged and operated completely different. But anyways, this subject is very interesting, as it's a very interesting dilemma for threat actors to consider whether these targets are actually worth to intrude, as it's clear that the degree of resources that have to be applied in order to target and also operate within this type of networks is really high. But let's talk specifically about Ramsay. What is the Ramsay framework? So Ramsay is a framework that is designed in order to steal sensitive documents, and it can be operated within air-gapped networks. The reason we call it Ramsay is because we found several references of the string Ramsay among all of the different components that we were able to find. And we believe Ramsay is actually the name that threat actors chose to call this toolkit. So we decided to call it as well. The first sample that we found was around March 2020, and it was uploaded from Japan to VirusTotal. And after technical analysis of this specific toolkit, we believe that it is possibly still at development stage. So here you can see a diagram of the anatomy of all of the 3 different variants that we were able to find. And there are 3 different versions, but really there are 2 versions, version 1 and version 2. On version 1, Ramsay gets dropped from a malicious document leveraging CVE 2017-0199, which is an OLE2 related vulnerability. And the main characteristics about this version is, first, that is very simple in structure in contrast with version 2, but also that the Ramsay agent in this version gets shipped as a standard PE executable. Then we have Ramsay version 2, in which we have 2 variants. Ramsay version 2.8 gets actually delivered as a decoy installer, which at some point drops a installer, which the installer itself drops a series of components. And among all of these components, there is one worth to highlight, which is the appearance of an spreader component, which is actually exclusive and unique for Ramsay version 2.8. And then on the other hand, we have Ramsay version 2.b, which again gets dropped from a malicious document, but this time leveraging CVE 2017-11AA2, which is a vulnerability related to a word equation editor. And there is one thing also that can be straight away spotted between Ramsay version 1 and Ramsay version 2. The first one is that there is always a rootkit component leveraged in version 2. Also, there are specific components that we can notice that are always leveraged in every single version, such as, for example, a USME component for performing privilege escalation, but also a WinRAR instance that gets leveraged in order to compress some of the files that Ramsay collects. But also it's important to mention that Ramsay's collection capability is actually remain and keep the same in these 3 different versions. So when we extracted the compilation metadata among all of the different versions from their correspondent artifacts, we found that the estimated development timeline ranged from September 2019 to March 2020. And although it might not seem like it, this is a pretty short development timeline. And this is a further lead for us to believe that this toolkit is indeed in its very early stages. So before I talk about the main capabilities, I first want to have a word in regards to Ramsay's agent, specifically Ramsay version 2's agent, which we believe is the most up-to-date version. So this Ramsay agent gets deployed as a DLL and gets leveraged via a specific DLL hijacking technique, which is known as phantom DLL hijacking, which in short terms, what this DLL hijacking technique basically consists of is by abusing backwards compatibility of specific Windows applications. So what happens is that specific Windows applications load specific dependencies, and on newer versions of these Windows applications, these dependencies are no longer needed. However, they still get loaded due to backwards compatibility reasons. So nothing stops threat actors from actually leveraging malicious versions of these DLLs. And that's exactly what phantom DLL hijacking consists of. But in regards to Ramsay, Ramsay leverages phantom DLL hijacking for two main reasons. One is to establish persistence of the main Ramsay installer, but also to distribute the Ramsay's agent capability. So this is an interesting design of choice. And what will happen is that depending on which process loads the Ramsay agent, a different display of capabilities will be performed. So this is a snippet of DLL main. And as we can see that the module name gets compared and a different set of code will be executed accordingly. But also it's important to note that the Ramsay's agents contain specific exports that are specific for concrete Windows services. And in fact, we found that Ramsay affected two main Windows services, which were WSearch, or also known as Windows Search Service, by hijacking msft.dll. And the other service which gets affected by Ramsay is MSDTC service, which gets impacted by hijacking a dependency of Oracle, which is OC.dll. So the main chain reaction of events that takes place after hijacking these DLLs is the following. So initially, after hijacking msft.dll, the Windows Search Service will be forced to be restarted. And when that happens, an instance of search indexer will be search indexer.exe will be deployed. At that time, Ramsay will be already running within the context of search indexer.exe. And what it will do is it will create a detached instance of search user host.exe. When Ramsay is loaded within search user host.exe, then it will basically perform its main capabilities, which range from collection to spreading, depending on Ramsay version, but it will also inject itself into explorer.exe. And once Ramsay is running within the context of explorer.exe, it will just collect recently opened Word documents from Office in intervals. On the other hand, we have MSDTC service, and when Ramsay runs within the context of msdtc.exe, it will just establish persistence of the Ramsay installer. And for any other process that Ramsay might get injected into, it will just deploy the compression and covert storage capabilities that we'll be talking next. So there is a lot that could be said about Ramsay. However, we decided to only talk about these three different topics in terms of its main capabilities, which we think that are the most relevant, which are collection and covert storage, command execution, and spreading. So in terms of collection, as we previously mentioned, Ramsay's main objective is to collect sensitive documents. And what it will do is it will search for Microsoft Word documents and text files from the system drive, remove media, and network shares. And these, the found files that Ramsay attempts to collect, they will first be stored in a preliminary collection directory. And the path of this preliminary collection directory might vary depending on Ramsay version. For each file that gets attempted to be collected, if it's a binary file, it will be attempted to be encrypted. So what will happen is that a buffer to be meant to be encrypted will be populated and will be allocated, and then this buffer will be populated first with information in regards of the file that was to be collected, such as the MD5 hash, the file, or the path of the original file. And then after this information is appended to the subject buffer, then the context of the file to be collected will be appended. And then this buffer will be attempted to be RC4 encrypted. What will happen is that a sequence of 16 bytes will be generated, and an MD5 hash will be attempted to be calculated. And then this MD5 hash will be the actual RC4 key. And this RC4 key will be unique for every file and could always be found at offset 0 of the RC4 encrypted blob. Another thing that Ramsay does is that this collection activity will be performed every day. So the way this is implemented is Ramsay will store the machine's local time, and it will check in intervals whether the local time has changed, and if it has changed, it will perform all of the collection activities. So that's the collection side of things, but there is also a more interesting side of things, which is the covert storage. And as we mentioned, Ramsay will attempt to collect in a preliminary directory all of the subject files to be collected. And this subject preliminary collection directory will be attempted to be compressed in intervals of 30 minutes. And this will be done with an instance of WinRAR that Ramsay stores contain, but also a hard-coded password will be leveraged for compression. And these are some of the passwords that we were able to find, and as you can see, they follow some common pattern. And what will happen is that once the preliminary collection directory gets compressed, Ramsay will save an instance of it in memory. And when this instance is saved in memory, the disk image will be removed. And then what will happen with this memory instance is that Ramsay will try to transform it in order to create what we call Ramsay containers. So the structure of Ramsay containers is the following. So we have a Ramsay magic, as we can see. Then we have a victim's machine hardware profile GUID. And then we have the compressed archive itself. However, an XOR layer will be applied to it. So these Ramsay containers is what Ramsay utilizes to covertly store all throughout the file system. And Ramsay will do this with the use of hooks in two APIs of kernel 32, which are write file and close handle. So what will happen is that when Ramsay gets injected into a foreign process, the auxiliary or preliminary collection directory will be attempted to be compressed, and a Ramsay container will be generated. At that point, a hook in write file will be installed. And this hook, what it will do is that it will read the file pointed to by the file handle, and it will check whether it contains a compound file header. And if it's the case, it will install another hook in close handle. And this close handle hook, what it will do is that right before the file gets closed, it will seek to the end of the file, and it will check whether a Ramsay container was actually generated. And if it was, it will append this Ramsay container at the end of the subject file. And depending on the extension of the subject file, either if it's a doc file footer will be appended at the end, otherwise just a sled of null bytes. And this is interesting because it denotes that threat actors actually took consideration of implementing anti-forensic capabilities, as for example this one, which its main objective is to hide from the naked eye the Ramsay containers appended to subject Microsoft compound files. So just as a brief summary of what we just covered, so we have the collector that scans files over the system drive, removable media and network drives, and all of the files found will be stored in a preliminary collection directory. And then the compressor will be deployed, and it will compress this preliminary collection directory to generate Ramsay containers, and these Ramsay containers will be the artifacts that will be appended at the end of Microsoft compound files throughout the file system. So now we're going to talk about command execution, and Ramsay does not support a network-based communication protocol. However, it does. Commands can be supplied to Ramsay via a file-based communication protocol. And these file communication protocols follows the same decentralized philosophy as covert storage, in the sense that what will happen is that so Ramsay will try to scan network shares and removable drives to find candidate files for control file documents. And these control file documents can be either Word documents, PDFs, or zip files. So what Ramsay will do for each candidate control document, it will try to search for two strings which denote two GUIDs, and it will try to search either of them. And one of them is dynamically generated and denote the specific GUID of the hardware profile of a victim. However, there is another one that is hard-coded, and there are two potential explanations of why this GUID appears. So one of them is that this GUID is nothing but a residual debugging artifact that Ramsay developers just neglect or simply forgot to remove in latest Ramsay versions. Or on the other hand, a more interesting hypothesis is that this GUID is actually the way that developers implemented the support of having control file documents which are victim agnostic. So each control file document will be targeted to be processed by a Ramsay agent running on a specific victim machine, and that will be denoted by the GUID. So meaning that if this global GUID is found, it means that that subject control file document will be executed by any victim. But anyways, if any of these two instances of GUIDs is found within the subject control document, then Ramsay will try to scan for a command signature. And there are three command signatures, which are the ones that you can see, which denote file execution, DLL load, and batch execution commands. So what will happen is that, let's say that a control document contains file execution signature. So what will happen is that right after the signature, there will be an artifact which is related to the command type. And in regards to file execution, that artifact will be a P executable. And then Ramsay, what will do is that it will actually execute this P executable. And something similar happens for the other two commands. However, just a different artifact will be leveraged instead. So right after Ramsay process each command document, each control document, what will happen is that specific artifacts related to the control file document will be removed. And these artifacts are the GUID, the signature, and the artifact dependent of the command type. And this is done in order to remove fingerprint of control documents. But also, what Ramsay will do is that once this control file document is restored to its original form, it will actually attempt to append a Ramsay container within the context of it. And this is interesting because it means that Ramsay does not waste a chance to append a Ramsay container, also while it's implementing different types of functionalities. Now we're going to talk about the spreading, and spreading is basically consists of a prepender file infector. And there is a correlation between command execution and spreading capabilities in Ramsay, meaning that there are the same drives are attempted to be scanned in both. And this hints how Ramsay might be actually used for lateral movement. We also found an eternal blue scanner implemented in Ramsay version 2.8, which tries to find vulnerable hosts to this vulnerability. And all of these hosts will be recorded and saved to a log file that at some point might be retrieved by operators and will be leveraged for lateral movement purpose, probably via a different channel. But in regards to the spreading via file infection, this is how it looks like. So we have a file that wants to be infected, and a series of artifacts will be prepended to this file. And these artifacts are an initial installer, a subject file deployer, a malware installer, and a Ramsay agent. So the way this works is that the initial installer will deploy both the subject file deployer and the malware installer, and the subject file deployer will be in charge to execute the original file, while the malware installer will execute the Ramsay agent. There is also something important to mention, which is that there is a series of tokens that Ramsay installer and spreader utilize in order to locate the different artifacts that they want to leverage. In regards specifically for the spreading, these artifacts are actually used for the file infection process. So these tokens are actually used as a way of implementing separators between artifacts. So what will Ramsay do is when it wants to locate a specific artifact, it will try to search the token in relation to that artifact. And please keep in mind this slide because it will become relevant in further slides. Also, something to keep in mind for further slides is that the main file infection process gets deployed once every 5 days. So now we're going to talk about the overlaps that we found in regards to Ramsay and DarkHotel. And we found various overlaps between Ramsay and a specific malware called Retro. And Retro is a backdoor that has been attributed to be part of DarkHotel's toolset. And DarkHotel itself is an allegedly Korean-speaking based APT, which has been active since at least 2007. And in regards to the overlaps that we were able to find, we classified them into 3 different types, which are open source tools and TTPs overlaps, artifact and code reuse overlaps, and contextual similarities courtesy of an operational security failure. So in regards to TTPs, we found an overlap in phantom DLL hijacking, but not only in regards to the specific technique, but also in regards to the dependencies that were abused, which are msfte.dll and OSI.dll, between others. And in regards to open source tools, we found that Retro and Ramsay were leveraging the same open source tools in order to perform some of their capabilities, such as USME for privilege escalation and improved reflective DLL injection for deploying some of their components. Remember the screenshot that I previously mentioned of the spreader and the Ramsay installer of the tokens that they utilize in order to locate specific artifacts within the context of themselves? So we found that these specific tokens were actually being reused in Retro as well. And we apparently these tokens are used in a different context in Retro, and they seem to be completely exclusive to Ramsay and Retro, and we weren't able to find them in any other malware family. We had several code reuse instances. However, unfortunately, I'm not going to be able to show all of them. However, I'm going to explain this specific instance, which I believe is the most insightful one, in my opinion. So Ramsay, one of the things he will do is that at some point he will try to profile the specific victim, and he will do this generating a GUID using the getCurrentHardwareProfile API. The problem with this API is the GUID that it returns is specific for the hardware, for the machine's hardware, but not as specific for machine or user instance. Therefore, Ramsay had to do something to cope with this issue. And the way it coped with this issue is by leveraging a specific encoding algorithm in order to make this UID less prone to generate duplicates for different victims. And this specific overlap does not only imply that Ramsay and Retro use a specific algorithm which is custom, which is interesting, but also having a bit more context of this overlap, it implies that Retro and Ramsay use the same scheme in order to profile victims, which, in my opinion, is a much more deeper connection. So now we're going to talk about the operational security failure, and let me tell you a short story. So initially, as we mentioned, the only instance of Ramsay that we initially had was the Ramsay Decoy 7-zip installer, which was in fact Ramsay version 2.8. And in order to find more instances, we attempted to scan our telemetry, and we found an instance of Ramsay version 2.b, which was dropped from a malicious document. Then after this, we wanted to find more instances of Ramsay, so we ran a VT retro hunt in order to find more instances of the installer or agents. But unfortunately, we were unsuccessful. However, we ran another series of retro hunts, and in order to find the malicious documents that leverage these Ramsay artifacts, and in this case, we were successful. In total, we found 23 related documents, and these documents weren't found initially all in one go. In fact, these documents were being uploaded as we were conducting the investigation, which in fact made the investigation itself very engaging. But some of these documents had very interesting characteristics, as these two documents that we can see, which their file names had suggested that they were testing documents and not actually being used in the wild. VirusTotal has a comment section, and this comment section is usually used by vendors or researchers that want to give additional context of a specific VT analysis. And we spotted that in the initial set of documents that we found, VMRay commented for every single one of those files. So what we ended up finding out is that there were VMRay analysis for each and every one of the documents that we found in VT. And after some brainstorming and further research, what we end up understanding is that the reason why these documents ended up in VT is because these documents were actually being uploaded to sandbox providers from community accounts, which what ended up happening is that these sandbox providers pivot the files to VT. And these sandbox providers it wasn't just one single instance, there were actually a few, which were AnyRun, Falcon, and VMRay. And in regards to the documents that we were able to find, some of them were legit, so that some of them were actually working Ramsay instances. That's how we were able to find Ramsay version 1. However, there were other instances that they were actually testing documents. For example, this specific instance that we found several times has the same delivery and exploit used by Ramsay version 2.b, but instead of leveraging Ramsay, it leverages an instance of calc.exe. And all of this activity is a pretty decent operational security failure, as threat actors or whoever was in charge of evaluating or trialing these documents were exposing these documents unintentionally, and these documents at some point I assumed that they were being integrated into their ongoing operations, but due to the fact that they were literally giving away these documents, they exposed these documents before they had the chance to do that. But not only that, after analyzing these documents a bit further, we find out that some of the documents have Korean-based strings within their metadata. And this aligns from what we know of DarkHotel, which is allegedly a Korean-speaking APT. And this insight basically help us and reinforce the technical overlaps that we previously discussed with this additional contextual overlap. So now we're going to talk about Ramsay's operation. So after we analyzed Ramsay, we concluded that the operators must be within the context of ESET networks. And what will happen is that Ramsay will intermittently hop over the air gap via removable drives. So unfortunately, we had restricted visibility of additional components, meaning that although we had various instances of Ramsay, nothing really points to the fact that Ramsay will be deployed just by itself. So possibly there is an additional component that is in charge of different roles within a Ramsay operation. However, we weren't able to find or have any other leads of which component this was. However, after we published our blog post of Ramsay, Tencent reported a follow-up in which they did a great job into correlating and explaining how Retro and Ramsay, in fact, they could be deployed together. And this is very interesting because this implies that there is a possibility that the very component that we are missing could be Retro. And if you are interested to know more about this, I will highly suggest to check the Tencent report because I think they did a great job in it. Also, another thing is that based on our hypothesis that Ramsay operates within adjacent networks, there must have been an initial intrusion vector to these adjacent networks, which is also unknown. Although we had some gaps and missing links, we were able to come up with this diagram, which is a pretty educated guess of how Ramsay could have been operated. So there will be initially an intrusion to a machine within an open network. And from all of the components that could be leveraged to this adjacent network, one of them will be Ramsay version 2.8. After Ramsay version 2.8 gets leveraged in this machine, if we remember, one of the main capabilities of Ramsay version 2.8 was the spreading. And the spreading, the way it's actually implemented is actually, it can actually work for two things. One is to actually propagate through other adjacent networks, but also there is also a possibility that this very spreading technique actually leads operators to land the Ramsay agent within their gap networks. So in that sense, they actually killing two birds in one go. Another interesting thing that Ramsay version 2.8 does is that it contains a very exhaustive logging system, which it records to a series of log files. And these log files, they might be at some point retrieved by operators. And the main incentive that of these log files is that they actually record the state of the proliferation of Ramsay. Furthermore, there must be an additional component, which is not Ramsay, which does the monitoring of insertion and removal of net shares and removal drives of the adjacent network. And this is possibly how an additional component gets into the equation. And then we have Ramsay version 2.b. So we mentioned that the spreading is actually done every 5 days. So we believe Ramsay version 2.b is how threat actors implemented a more direct way of leveraging Ramsay without actually having the constraint of these 5 days. So what will happen is that when a net share or a removable drive gets one of these Ramsay components, either the Ramsay version 2.b malicious document or any P executable that gets infected by Ramsay version 2.8, when these devices get plugged to the air gap network, they will be leveraged via user execution, and the Ramsay agent will be deployed. When this happens, the Ramsay agent will do its malicious functionality as to do the collection and cover storage capabilities and store and append the Ramsay containers all throughout the file system. At some point, these Ramsay containers will want to be exfiltrated. So what we believe it will happen is that, again, monitoring for the insertion of a removable drive of an edge will be done, and a specific control document will be inserted to this device. Then this device, when it gets plugged to their gap network, Ramsay will have means in order to detect and process this control document. And the command of this control document, probably what we'll leverage is a scanning of Ramsay containers within the file system, and we'll copy these Ramsay containers to the subject device and probably even compress them. And then when this device gets plugged back to the adjacent network, then operators will be able to retrieve it, and that's how the exfiltration basically is done. So conclusion, Ramsay has gone through various development stages, and we think that it's probably still at development stage, although it's likely being used as well in the wild. We had a restricted visibility of victims and additional related components due to the very nature of air gaps. So a scarcity of a network-based communication channel also implies that there's going to be a scarcity of software that relies on a network-based communication channel. And this includes antivirus software, which has a direct impact in victim visibility. And we believe that Ramsay is the product of DarkHotel of a related subgroup, especially after the validation of different vendors, in specifically Tencent. And we came up with some prevention suggestions in order to mitigate Ramsay. So one of the things that has to be done is that because we believe that operators have long-term persistence in adjacent networks, these networks have to be monitored in order to mitigate this foothold. Also, it's a good practice to deploy security measures within air-gapped networks, and a good solution to this is to deploy an EDR into them. But if any of these things fail, there is always an auxiliary measure that can be applied, which is to apply secure protocols to validate the integrity of devices that connects to or from the isolated networks. So this is done in order to, so we know that Ramsay operates through the insertion and removal of removable media. So even if the malware gets executed successfully within the air gap, by applying this measure, the malware won't be able to operate. So that will be the end of the presentation, and I hope that you enjoyed it, and I'll be happy to answer the Q&A. And thanks very much.